In the depths of the unknown, radio waves like dark shows, mysteries unwrapped and shown. Solutions defy what we know, hidden truths we're never alone. Follow me down the rabbit hole, secrets and binding codes, breaking the mold, define control. Power bursts without a soul. In this digital catacomb, we spread the truth of the truly bold. Epics we uncover, forbidden undercover. Rise against the silence, breaking through defiance. Energy from the ether flow, quantum realms, the science of flow. Whispers from ancients echo, gravity's on hold, let's go. Beyond the reach of their woe, floating with you ever cold, bridge the gaps all light shows. Pioneer, on we roll, past the famous say so. This is all been our road. Epics we uncover, forbidden undercover. Rise against the silence, breaking through defiance. Synth waves crashing, hearts collide. Revolution of the mind. Let the codes and truths unwind. Illumination find. Epics we uncover, forbidden undercover. Rise against the silence, breaking through defiance.
And in the depths of shattered halls, I wandered all alone.
Casting whispers, binding chains, demons of my own. Toxic deafening, down spread on my frail soul. I once spin my mirror, haunted by my role. Playing the echoes of my cries, just till I emerge, guiding me to where my true results are. Now I rise from the shadows with wings of fire I ascend, free from the chains of sorrow. All these paths are forever deepened. Shattered glass beneath my feet, scars I wear but dry. Stormy nights just turn to dawn, I wear truth as my guide. Anxiety's dissolved in the sun's golden rays. See my destiny through time and space. The fears that once consumed me now they take. For in my heart a new world is proclaimed. Now I rise from the shadows with wings of fire I ascend, free from the chains of sorrow. On this path I'll forever depend. With symmetry I found the power. Blessings granted by the hour. Together we will come away. Revolution calls and I'm not strong. Now I rise from the shadows with wings of fire I ascend, free from the chains of sorrow. On this path I'll forever depend. In base lab alone with my mind, scribbled theories they all refuse to find. I've been working on energy for a brand new day, but even in the crowd I'm still a castaway. Alienated from the aids of added nature in disguise. Ideas ahead of time dismissed with narrow eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Talking love 0 point, the points lost on them. Gather structures coming from the same old stem. They laugh like I'm crazy, but I see it all so clear. Exploited labor, unheard, injustice burning ears. Fighting for a change in this wasteland of noise. But they call me foolish, wanting shed boys. Benefactor boy, dreaming about the world we can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice?
Alright, welcome, and welcome back to the Benefactor's Guide to Free Energy Devices. This episode is the definitive evidence episode, the one that you should all be watching before diving into any of the individual projects and do-it-yourself experiments that I have laid out for you. The objective of this presentation today is not to prove over unity. Rather, the goal is to demonstrate how a consistent pattern of observations collected over the last 2 or 3 years of experimentation gradually led to the formation of the synthetic AC model. By presenting each experiment to you in somewhat of a chronological order, you can evaluate them for yourself and decide whether these independent observations appear to support a common underlying electrical phenomenon. This is not a presentation based on belief. There's a presentation based on evidence that I have collected. So let's take a look at where the evidence led me over the past 3 years. So every major discovery begins the same way, with an observation that doesn't quite fit. At first, those anomalies seem isolated, they seem disconnected, or even insignificant. But over time, patterns begin to emerge if you pay attention. What once looked like unrelated experiments slowly became pieces to a much larger puzzle. For the last several years, I've been documenting every experiment I performed with these vortex coils using solid-state pulse driver circuits and negatively charged batteries, recording the battery behavior and the resonant waveforms that we've discovered, and documenting back EMF recovery effects. Now, initially, none of these projects were intended to support a single theory. Each one was simply an attempt to understand an unexpected result or behavior. At first glance, these looked like unrelated observations, anomalies that didn't quite fit together using traditional explanation. They weren't, by any means. They were all connected. Piece by piece, they began to fit together into what I now call the synthetic AC model. Now, along the way came observations involving the solid-state pulse driver circuits that we're working with, specifically the Joule thief. We've had observations on battery reversal while powering a device, resonant pulsed waveforms recorded with oscilloscopes, energy partitioning effects observed and calculated, field cavitation theory, which is the mechanism of action at play, and back EMF recycling, which explains some of these efficiency gains in the system that traditional theories just can't explain. Each discovery naturally led to the next and eventually revealed an overlying pattern that I could no longer ignore. Now, this episode isn't introducing another new experiment, but rather it's compiling every piece of evidence collected so far and asking some important questions. One being, do these observations point towards a single underlying electrical phenomenon? Now, remember, my goal isn't to convince you that I'm right. My goal is to show you every experiment that is relevant, every oscilloscope capture, every measurement, every success, every failure, and every unexpected observation that is relevant to this presentation so that you can decide for yourself whether these discoveries are connected or not and whether they make sense under the synthetic AC model that we're trying to develop to understand some of these anomalies. So we're going to let you decide and be the ultimate arbiter of the synthetic AC model tonight, right here on the Benefactor's Guide to Free Energy Devices. Don't forget to hit the like button and subscribe for more revolutionary content. Alright, so before examining the evidence, we need to define exactly what we're trying to explain here. What is synthetic AC? Now, every scientific model exists because existing explanations leave unanswered questions. They just simply fail to capture what's really going on in some anomalies, in some areas of science that produce anomalies. So, the synthetic AC model is my attempt at explaining a series of observations that repeatedly appear throughout multiple independent experiments with something called a Rodin coil. I call it the vortex coil because there are different variations of the Rodin coil, and it gets kind of confusing. So we're just going to generalize these coils by calling them vortex coils, just to keep it simple, because that is the main mechanism that's being utilized here. So it's not intended to replace conventional electrical theory. That has to be emphasized here. Synthetic AC rather is being used to explore whether there's an overlooked interaction between forward electromotive force inductive collapse and resonance that kind of becomes visible under specific operating conditions, specifically when we're using vortex coils in our pulse-driven systems. So we must first take a look at traditional systems. So a traditional pulse works like this. You have the forward pulse that creates the electromagnetic field. And when that pulse shuts off, it creates a collapse. The field, we call it an inductive collapse because it induces an electrical current as it collapses. And that inductive collapse produces back electromotive force, which is the energy that you get from the collapse as a reaction. Now, that back EMF in traditional systems is just simply discarded or ultimately underutilized in some minor way, and there's a lot of energy loss as a result. The synthetic AC model works a little bit differently. It aims to recycle some of that lost energy. Now, we have the forward pulse that creates the electromagnetic field in the coil. Now, when that pulse collapses, and it collapses suddenly, we use high frequencies to create an impulse instead of just a traditional pulse. And when that inductive collapse happens, it creates a interaction between the forward electromotive force and the back EMF. Two opposing voltage systems that seem to exist simultaneously, therefore happen when they're synchronized correctly. We see this as evidence, and we specifically see this as evidence playing out as recording a 10 positive volts on the output rail and simultaneously recording negative 168 volts on the same output rail, which just simply shouldn't happen in a traditional system. That would fry components, that would render your system either extremely inefficient or in most cases not able to turn on at all. So there's an interaction between the two events that's creating the alternating electrical behavior. It's a synthesized alternating current instead of just using the same energy and reversing polarity on it. So when timed correctly and using the vortex geometry for your coil, resonance can be achieved between the two energy events. This energy is synergized and connected via a field bridge, which can then be partitioned and recycled. The working hypothesis is that the synthetic AC model proposes, the working hypothesis for the synthetic AC model is that it proposes that by deliberately synchronizing forward EMF and inductive collapse events, a circuit can create an alternating electrical state while still operating from a DC source. This synthesized alternating behavior may allow resonant energy exchange that conventional pulse circuits simply suppress or ignore altogether. So we're going to watch the synthetic AC explainer video, which goes into a lot more detail. But while we're watching it, I have some questions for you that you might have you might benefit from asking yourself while you're watching the video. And we'll go over these questions afterwards. But think about what exactly the synthetic AC model is, first and foremost. I want you to think about how it differs from ordinary AC and ordinary DC. Can a DC circuit produce alternating electrical behavior without an inverter? And why should back EMF be viewed as part of the circuit instead of waste? Could forward EMF and back EMF be operating together in sync, in harmony? So think about those questions while we go into this explainer video, and we'll answer those questions in more detail when we come back from the video.
Let's dive right in. Have you ever suspected that our standard measurement tools are, well, completely failing to capture the true efficiency of nonlinear, open energy systems? More importantly, how do we mathematically prove they're missing the big picture? Today, we're unpacking a really fascinating peer-reviewed proposal aimed directly at electrical engineers. We're looking at the synthetic AC model. It's a groundbreaking framework that literally challenges the foundation of how we measure electrical efficiency. Here's our agenda for today. We'll start with the RMS measurement problem, then move into building on Bearden and Bedini. After that, true versus synthetic AC, followed by partitioning energy events. Then we'll look at the corrected COPE methodology, and finally, wrap up with field cavitation and geometry. Section 1. The RMS measurement problem. So, to kick things off, we absolutely have to address a glaring mathematical blind spot built right into standard engineering tools. If we miss this, the whole model falls apart. Mainstream tools rely heavily on the root mean square or RMS formula. But here's the catch. RMS acts kind of like a statistical blender. It takes these sharp, high-energy spikes, like a sudden reactive negative 168-volt output, and artificially smooths them out into this gentle, artificial average. Because you're dealing with squaring and square root operations, RMS values just don't obey linear addition. They effectively mask the raw, instantaneous reality of what the energy is actually doing in the circuit. And the root of this error? It's pretty profound. Standard engineering treats open, non-equilibrium systems as if they're governed by equilibrium thermodynamics. It's like looking at stagnant water in a sealed pot, uniform temperature, zero net flow. But these non-linear systems, they're totally open. You really have to think of them more like a persistent whirlpool that's continuously maintained by environmental gradients. If you try to use closed system math on an open system whirlpool, you are always going to get the wrong answer. Which brings us to Section 2, building on Bearden and Bedini. To actually build a correct mathematical framework for these open systems, we get to stand on the shoulders of the pioneers who first spotted these anomalies. This methodology doesn't just pull ideas out of thin air. Instead, it unites proven concepts. It takes Tom Bearden's brilliant work on dipole preservation and asymmetric regauging and weaves it seamlessly with John Bedini's pulse motor principles and his capture of the radiant collapse component. Add in Tesla's time asymmetric impulse technology, and we're combining all these foundational observations into one incredibly coherent, measurable, and rigorously mathematical framework. Moving right along to Section 3, true versus synthetic AC. This is where we hit a really critical taxonomy correction. We have got to separate actual alternating current from synthetically constructed bidirectional waveforms. Think of true AC like a closed pipe where water is shoved forward and then yanked back along the exact same path. It's constantly fighting its own momentum, which creates friction and heat. Every forward push gets completely undone by the backward pull. But synthetic AC? It's like two people taking turns firing ping pong balls into a central zone. It's an open, carefully choreographed sequence of totally independent, time asymmetric events. It isn't just reversing, it's sequencing. And understanding this difference highlights exactly why that RMS blind spot is so dangerous. If you compare classical AC to synthetic AC, the two waveforms might look completely identical on an RMS meter, literally indistinguishable. But the reality of how they're generated, how they release energy, and how they actually perform work is radically different. Grouping them together is a huge inherent contradiction, and that's exactly what this new model fixes. Section 4, partitioning energy events. Now that we've established they're different, we need to talk about how to partition these actual energy events to measure them properly. But before we partition anything, we have to toss out the loop fallacy. Conventional electronics teaches us that energy flows inside the wire in a neat little closed loop, but in reality, energy travels through the space around the wire as an electromagnetic field envelope. Engineers know this as the Poynting vector. And because the energy is sitting in the space, the forward work and the backward radiant collapse don't actually have to fight each other inside the same wire. We can geometrically guide them along entirely separate pathways. Just look at these oscilloscope captures. When energy is partitioned correctly using specialized geometry and high-speed switching, something beautiful happens. Over on the microscale, you see these chaotic, bouncing, nested harmonics, but zoom out to the macro scale, and those exact same harmonics perfectly converge into an incredibly smooth, emergent, and highly efficient sine wave. The energy isn't just sloshing back and forth anymore, it's genuinely synergizing. Section 5. The corrected COP methodology. Let's look at the new mathematical methodology and see how it builds a rigorously corrected coefficient of performance, or COP. This is exactly what electrical engineers have been waiting for. To actually prove the COP is greater than 1, we have to follow some precise steps. We start by completely abandoning RMS averaging. Instead, we use instantaneous power integration. This lets our framework treat each temporal window as an isolated thermodynamic event. We measure absolutely everything in units of work, joules. This allows us to mathematically validate the system's true efficiency, completely bypassing that statistical blurring of RMS. First up, we calculate the true instantaneous input energy. Because the backward pulse dynamically alters the local scalar potential of the battery source, we simply can't use average input current anymore. It won't work. We have to dynamically account for phase angles. We do this by taking the integral of the instantaneous product of input voltage and current, but we do it at extremely high sampling frequencies, exactly as you see in this equation. Next, because the system physically partitions the energy into distinct spatial and temporal pathways, we have to compute the work for each path independently. So we calculate the forward energy heading to the load and the backward recovery energy returning to the source, completely independently in absolute joules. And remember, joules, unlike RMS values, can actually be added linearly. Once we've isolated those components, we just add the joules together to get our corrected unified COP formula. The COP equals the forward work plus the backward work divided by the true input energy. This approach relies strictly on calculus and the absolute conservation of energy across isolated partitioned events. It sets an incredibly rigorous standard for engineers. Honestly, it's pretty airtight. And finally, Section 6, Field Cavitation and Geometry. Now, you might be wondering, what physical mechanism actually allows us to partition these forward and backward events in the real world? The answer lies in something called field cavitation. It's a mechanism driven entirely by specific spatial geometry. Coils with really unique winding geometries, like the ABHA or Rodin coil, naturally structure the electromagnetic field so that counter-rotating components occupy the exact same spatial volume. This forces simultaneous field compression and rarefaction. You are literally cavitating the electromagnetic field, kind of like how bubbles cavitate in a fluid. Because of this specialized geometry, a localized zero-point void forms right at the equator. Think of it like a highly stable, localized desktop black hole. What this void does is critically delay the dipole collapse. By stopping the immediate recombination of the field components, it buys us the necessary time to partition and actually harvest that backward recovery energy. And to prove this is truly a geometric phenomenon, we can just change the coil. If we use the exact same circuit, but swap out the AMBHA coil for a standard flat pancake coil, that beautiful, highly efficient sine wave we saw earlier distorts into this inefficient, bell-shaped curve. It proves beyond a shadow of a doubt that visual similarity on an oscilloscope does not guarantee similar thermodynamic performance. The geometry itself is doing the heavy lifting here. Ultimately, this new taxonomy completely demystifies the coil. Our methodology proves that energy behavior is geometry dependent, well before it is circuit dependent. When you design it correctly, the coil isn't just a basic inductor or a transformer anymore. It becomes a unified, free-flowing, distributed element network. It's a complete resonant electromagnetic structure. This leaves us with a massive, literally paradigm-shifting question. If standard RMS meters are mathematically blinding us to the partitioned realities of nonlinear systems, if they are literally averaging away the evidence of over-unity efficiency, we have to ask ourselves, what other incredible thermodynamic breakthroughs are currently hiding in plain sight, just waiting for the right mathematical framework to finally reveal them? Thank you so much for joining me on this explainer. Keep asking the big questions, and I'll catch you next time.
Alright, so I hope that explainer video helps you answer the questions that we had before I started the video. Specifically, what exactly is synthetic AC and the synthetic AC model? Well, synthetic AC at its core is a taxonomy correction more than anything else, and that has to be emphasized 100%. It says that creating alternating behavior within a circuit using bidirectional pulsed DC is not the same classification as traditional AC that uses the same energy to reverse polarity. And since it does not use the same energy, it uses two or more independent pulsed events. Since it doesn't use the same energy, you don't have the same resistance as in traditional AC. You simply have more efficiency just because you're not fighting yourself. Thus, this major classification correction is at the heart of the synthetic AC model. Now let's look at how the synthetic AC model differs from ordinary AC or ordinary DC. Well, the synthetic AC method differs in two major ways. It utilizes circuit timing and geometry to induce field cavitation. Now, this cavitation process allows the system to extract extra energy from an environmental gradient while also synergizing the forward and backward pulses to be in a state of highly efficient resonance. The second difference is that in traditional AC and traditional DC systems, the reactive collapse component, the back EMF event, is either underutilized or wasted entirely, just dumped, wasted. In our model, we capture and recycle this back EMF component using a synergized field bridge that field cavitation facilitates, and the energy partitioning that goes along with it. You have combined the forward and the backward fields in a way that they're synergized and in harmony, but separating the two currents associated with them, sending the positive to the light source or output, while the backward component is recycled back to the battery, the source. Now, this is the fundamentals of Tom Bearden's asymmetric regauging principles. You want to partition that energy. The next question, can a DC circuit produce alternating electrical behavior without an inverter? Well, this is an interesting question, but essentially yes and no, because while the Rodin coil produces these unique effects of transforming the energy, it can be classified as a transformer, but at the same time, it's more than a transformer, so it's a separate category. So I would say yes. One of the unique effects that has always been documented with the Rodin coil, and that I've tried to explain with the synthetic AC model for the first time, is the Rodin coil has this natural ability to step up or step down voltage with a 1-to-1 coil of wire, a 1-to-1 ratio of wire. So in traditional systems, you require an asymmetric ratio of coils. You have two coils in a traditional transformer. One has more or less winds than the other one. In the Rodin coil, this specific variation, we have a 1-to-1 ratio. It's the same bundle of wire just split up into two channels. So it's not asymmetric. So how do we explain this transformation effect? How are we getting a step up voltage with a 1-to-1 ratio of coil? We explain this unique effect as a byproduct of field cavitation. Now the next question, why should back EMF be viewed as part of the circuit instead of just simply waste? This is the most important question, because nature you want you to think about this for a second, because nature gives you back energy to stabilize any system that is undergoing disequilibrium. So you can imagine this: if you push a swing, right? Gravity pushes back to stabilize and find that balance. A coil is no different in that respect. Or a trampoline. You push on a trampoline and it bounces back. When you put energy into an electromagnetic coil, it produces an electromagnetic field. If you pulse that energy fast enough, the field is created and then snaps closed. Once the coil collapse snap happens, nature sends a massive spike of reactive energy into the system. But why does it do this? This is the most important question that I don't think anybody has ever asked, at least not for a while. Why does it give you all this energy back? Well, it's simple in my answer, because nature doesn't like imbalance in systems. Nature strives for balance. Nature strives to find equilibrium, no matter what system you're looking at. It's literally giving us the energy we need to stabilize our system. And what do we do with it? Most engineers just dump it and call it a day. They're too lazy to work with it, so they call it noise and move on. Not in our systems. We try to capture and recycle this energy. Nature's giving us this back EMF for a reason, okay? Now, the next question, could forward EMF and back EMF be operating together? And the answer to this, in my opinion, is an astounding yes, in these types of systems at least. This is the number one question I've had since I've developed the synthetic AC model, and the answer is absolutely yes. We simply should not see an asymmetrical difference in voltage potential in the same output rail. Traditional systems should not even be able to function like this, let alone display extremely high efficiencies and Q factors. So this is extremely important. We're getting 10 positive volts on the output rail, but simultaneously negative 168 volts. And the system isn't blowing up. It's actually performing quite well, and unlike traditional inverters, might I add, because this system is doing the same thing as an inverter, right? It's taking a DC signal from the battery and changing it into an AC output for this light source. I'll turn it on in a minute. I have it charging on the Bedini SSG, the battery. But what it's doing is it's acting as an inverter. But what do inverters need to stay functional? They need really, really fast fans, high RPM fans, very loud, very noisy, because they get hot. The coils inside them get very hot. This coil does not get above ambient temperature, while it's outperforming every other off-the-shelf inverter. We have to understand why it's doing this, though. We can't just say, hey, this is a cool effect, you know, we can use this for something. We have to ask the question, why? Why is it operating like this? Why is it not producing any heat? So now we go into replicating experiments. Now, replication is where curiosity becomes investigation. Rather than accepting someone else's conclusions, I rebuilt circuits for myself to try and determine if there was any real credibility to some of the claims of the coil. Multiple people have claimed that the coil produces enormous efficiency, and I just had to verify it for myself. Now, every waveform, every measurement, and modification became another opportunity to separate reproducible observations from speculation. Allowed me to form my own opinions and theories about the coil. And one of those observations became very important, because when we were replicating one of Daniel Nunez's setups, a modified Joule Thief using the Vortex coil, we discovered something that I had to label because it didn't really have a classification. So at the time I labeled it a resonant pulsed waveform. Now this became the linchpin of the synthetic AC model. At this time I didn't have a model, I just had this unique waveform and the 3 defining characteristics. Well, technically 4. We'll go into that in a minute. But we're going to watch a video of this unique waveform that I captured that basically gives a ton of support to the synthetic AC model, specifically in the claim that under the right circumstances, the forward and backward components can be synergized using a field bridge. Now we're using a floating probe to pick up the field interaction with this oscilloscope reading. That's very important because traditional measurements would have you ground the probe, and it is important to pick up those measurements as well, but I think a lot of areas of these overlooked anomalies, for lack of a better word, I think a lot of areas of science that overlooked these anomalies did so because they just didn't use the correct method. So it's very untraditional the way that you have to observe this stuff. First of all, you use a floating probe, which is counterintuitive. A standard engineer doesn't just, pick up a high-speed oscilloscope and use a floating probe unless they're, looking for something specific, which we are. So specifically, we're looking for the field interaction. Now, when you ground the probe, you ground out that back EMF component, that back EMF field interaction. So you don't see the full picture of interaction that's happening. Now, it might not be the whole picture, but it is important because when you compare it to other waveforms, certain characteristics start to appear that are unique to this setup, that add credibility to the synthetic AC model and when trying to understand what this system is actually doing. Now, before we watch this video, I want you to go into the video with a couple of questions. Did this replication confirm the original observations from Daniel Nunez's high efficiency claims? Which components mattered the most? What unexpected behavior appeared when we captured the waveform with the floating probe on our oscilloscope, our high-speed oscilloscope? So think about some of these questions, and we're going to answer them after we return from the video that shows the 3 defining characteristics and the 4th one that's separate from those 3. The 4 defining characteristics of the resonant pulsed waveform. Alright, so we now have the oscilloscope hooked up to positive of the lumen lamp output to the load, to the light. Okay, and look at this waveform. It's completely different. This is a different beast entirely. Okay? You don't have that ringing. It's a little bit, but not in the same realm as what we're getting with the lightning thief. So look at this. This is very interesting. It's a nice waveform, but it is not the same. It's not, I don't think it's a resonant waveform. I don't know. I have to do some analysis and consult with a couple of individuals. It looks like it's slightly trying to ring. See? But not in the same realm that we... So keep in mind that when you pause the oscilloscope, this is just one signal. It's just one signal bouncing off of itself, but we're comparing different... What we're doing is we're taking the same circuit, the modified Joule Thief circuit, and we're comparing different coils using the high-speed oscilloscope and a floating probe. And we're comparing... Yeah, so we're comparing one to another, and At this point, we already knew that the lumen lamp was less efficient, at least based on standard RMS calculations. Michel Morel, who invented the lumen lamp, he actually calculated it to be very inefficient at around like 71%. But, you know, again, that's using RMS values. So that might be a little closer to maybe, I don't know, 80 or 90, but it's definitely a lot less efficient than the vortex coil that we're using, which is basically taking that pancake coil and extending it in a third dimension, right? We're extending that axis a little bit and creating a true vortex. So instead of just a spiral, right? A spiral is two-dimensional, or whereas a vortex is three-dimensional. We're adding that extra dimension into the geometry of the coil, and we're comparing the waveforms. And this is the lumen lamp. Comparing it to the waveform, the resonant pulsed waveform of the vortex coil, is almost like night and day, because you see some of the same similar things. They look similar. They'll trick you. They look similar because the coil just naturally does this thing where it wants to find resonance. So they look similar, but the efficiencies are different, noticeably different. And you can see this when you zoom out on the macro scale. It's not a smooth sine wave as we see in the resonant pulsed waveform. It's more of a bell-shaped curve, indicating a inefficient transfer of energy from forward to backward, right? You have the forward component and the backward component represented there in the full picture, where you see the positive and the negative on the graph. And that's indicative, in my opinion, that the transfer of energy is just not, it's not happening to create a field bridge where it's, I guess you can kind of imagine it as two magnets where one is just close enough to not exactly attract all the way, but not far enough where it's going to just pop away and repel. So it's like just close enough where it's chasing each other and creating a little tiny bit of a window where you can partition the two current events that are happening after the field is formed. So this is the way that we can actually gauge, visually what's going on in the system. And in my opinion, the results are kind of like night and day. See? But not in the same realm that we were with the lightning thief. Here, I'll hook up the probe to the lightning thief right now and show you. We get the same waveform. And look at this. This is like more of a perfect sine wave when we zoom out. And look at all those nested harmonics that are like making up that sine wave. It's very thick. Let's go down a little bit because we had to. Damn, boy, she thick! Adjust for the other device. So look at this. So look at all those nested harmonics. That's one wave bouncing off of itself. And then when you zoom all the way in, it's just not. It's almost like it's a. It is. It's almost. So on the lumen lamp, on the pancake coil, it's almost like when you zoom in, it's almost like it's. You see that kind of same almost pinch point, but it's not the same in terms of the sideband activity. It's a lot more minimal. And now here, comparing that, we see it's just here. If I go back a little bit. Yeah, no, that's not it. Okay, so, yeah, see, zooming in. What we're getting with the lightning thief. Okay, so look at this. Look at this. Okay, so you see that? I should have paused it in the video in retrospect, but this is the micro scale. By changing the coil, look at that. There's almost no sideband activity. I mean, it looks a little thick, but it's not like it's a pinch point, right? It's not like, it doesn't look like two tornadoes touching each other. It's just kind of like this smooth transition. And I think that's important. That's an important detail. To adjust for the other device. So look at this. Now look at that in comparison. It's almost like it's it is. It's almost like it's synergy, and it's like harmonizing or reflecting off of itself in a very peculiar way. Now this could be indication of field cavitation happening successfully. It could be an indication of a field bridge type of effect between the forward and backward components. It could be a lot of things. There are a couple of ideas that I have, but at the end of the day, these are just theories. So as the synthetic AC model evolves and more tests are done, things could change, things could be refined. We could drastically refine our understanding of what this is, 3 weeks from now. But as of now, I believe it is the kind of interaction between the forward and back events that potentially indicate both a field bridge and field cavitation. Not that field cavitation isn't happening in the other coil. Maybe it's happening and it's not satisfying requirements to be as successful as this system. So there's all sorts of variables that we have to consider going into refining the model as we test. We have to keep an open mind that certain things might have to be
that seems to
changed.
Be very, very stable when you zoom out.
But look at that. It's like, it's insane. And keep in mind, this is like one of the best oscilloscopes you can buy on Amazon. It's rated for extremely high speeds. This was having trouble picking it up. So that's how much activity was on it was picking up. So much activity that it's hard for this system to catch up. And this system has a very high resolution. So it just shows you what this coil is capable of. And again, we're only running off of, like a 12-volt battery, So it's not a lot of power input by any means. So now we're going to answer a couple of questions and go into another couple of videos. So, did the replication confirm the original observations of high efficiency that Daniel Nunez claimed? And I would say absolutely. We got the exact same amazing efficiency that Daniel claimed on his system. Almost exact same numbers, in fact. However, I think an important caveat here is that when trying to measure the efficiency of Daniel's system, he went into it with, standard engineering methods, which employ, root mean square, and not really understanding how to capture the efficiency of these types of systems. In my opinion, like going into this and trying to understand, why he was getting so much efficiency, why I'm getting so much efficiency, and we just can't see it with our scopes. The synthetic AC model mathematical framework that we're going to go into, it really kind of gives a practical solution to that big glaring problem that a lot of us have had in this area of alternative energy research, is trying to utilize what we call negative electricity in a way that works with our system instead of just dumping it or grounding it out. And how do you capture that kind of energy if our systems, our standard meters, are designed not to see it? So the way that they look at it literally blinds us to some of these effects. And I think we have to evolve our understanding and this mathematical solution didn't come from me. Honestly, it was a solution that I looked into. I asked questions through, different chat bots and through professionals, colleagues that I know personally that work with me on the podcast hosted by Mike Kay from Faraday Research, his League of Extraordinary Inventors podcast. We have a bunch of great collaborators. Phil Dubar, he is a brilliant physicist and mathematician. So, I consulted with a lot of different individuals, and I also used artificial intelligence to help me find a solution to this. And the instantaneous power integration solution was the only method that I could come up with that I saw real potential in. So, and it wasn't just me; others kind of saw potential in it as well. So I think we're all starting to notice, like, okay, there's something wrong with the standard way we're measuring these types of systems. We have to evolve our way of measuring. We have to change. We have to adapt the coefficient of performance formula. And I think, and if we're able to do that, we're going to see some interesting results regarding both Daniel Nunez's work and the work of people who replicated his systems, such as what we're doing here. My prediction is that we're not going to see phenomenal over unity, but I believe that by doing this instantaneous power method and measuring everything in absolute units of work, which is, the joule, I believe that we will see, at the very least, a tiny bit of over unity. We will probably capture about if I had to guess right now, just based on my raw instinct, I would say we would capture at least a COP of 1.2 or 1.3 with just experiencing how long the system lasts compared to a traditional inverter, and then comparing that using the same battery, same capacity, and then understanding that the duty cycle isn't, like 10%, or it's not on at a lower rate of time than the standard inverter that we're using as a control. No, it's 50-50. So, going into it, realizing that all these different variables we have to compare, it just beats it. It still, like, it outperforms it, and it just doesn't make any sense. Even a theoretical 100% efficiency would be a lot less efficient than what we're seeing with our Lightning Thief, which is behind me powering my. Well, it's not on now, but I'll turn it on in a minute. It's used to power my lab light. So now, when we first started with the system, it wasn't powerful enough. It wasn't bright enough to light my lab. I actually used it as a night light. It wasn't very bright at all. And we've used these kinds of trial and error and mistakes and formulating understandings, going back to first principle thinking, to adapt the system to what it is now. And when we look back at that in retrospect, we can kind of formulate and look at the patterns and formulate a coherent model of what's actually happening, a theory of what's actually happening. And that's really what we've done here with the synthetic AC model, is taking the work of others and trying to explain it, asking the fundamental questions to get to the root of why these systems behave the way they do, in order to adapt them, improve upon them. How can you improve upon a system if you're just randomly swapping components or trying this idea or that idea and seeing if it fits? That only works to a certain extent, but if you want to really scale a system to be useful on a mass, scale, then you really have to have a model to understand everything. And I believe this is not the ultimate answer. It's not like a unifying model, but it is a model that unifies, and it is a fundamental first step. That reclassification is important. I mean, it's something that's gone overlooked for a long period of time in science. That right there is a fact, and it is a raw, cold unassailable fact. You cannot deny that we are lumping two fundamentally different behaviors of systems into one category simply just as a generalization error, right? It might not be deliberate, but, you know, these distinctions matter. And when you separate those two types of systems, you know, traditional AC from synthesized AC, then you can start to see, like, oh, this aspect of our system makes sense. So that's really all we've done here is try to make sense of everything. And as a result of doing that, we've had certain components that mattered more than others. And that goes into our next question: which components mattered? So the main components that mattered were the transistor and diode. Okay, those were the two focusing components that really mattered with the efficiency of the system. Now we want a high switching speed because the system is very fast. The frequency is extremely fast. Remember, we're using a pulse driver circuit. It's called a pulse driver, but it's more accurately labeled an impulse driver. It's not a traditional pulse driver. It's very, very fast. Now remember, the distinction between impulse and pulse matters here, right? Remember a pulse. What is a pulse? A pulse is a frequency that has a start and stop, right? Think of, you know, me clapping. So that repeating clap has a start and stop. But the clap itself is an impulse. And what is an impulse? An impulse doesn't have a start and stop. Well, it does, but they overlap. They're the same event. So imagine a stone being dropped into water, right? The stone hits the water, and it creates that big reactive wave. Now, this happens all at once, right? So it's not something that starts and then stops. The stone hits the water. It hits the water instantaneously. The clap happens instantaneously. The repetitive clap happens at a frequency that has a start and stop point. But the clap itself, the individual event, that is an impulse. So those differences matter because this means we're dealing with extremely fast frequencies. And because of that, we need very fast reactive components to complement the system and the coil. So the transistor and diode are going to be very important when doing experiments with these setups. Now we go into the last question. What unexpected behavior appeared? Well, specifically with the modified Joule Thief circuit, the most unexpected behavior has to be the Joule Thief setup. And it literally doubled the brightness of the output without touching the source battery drain, which was phenomenal. Another unexpected thing that happened in a different system was the battery reversal while under active load, but we're going to get into that in a minute because that came a little bit later. But I want to focus on the Joule Thief setup because it's very important. Again, we're dealing with a system that fundamentally works off of field interaction as the primary component. Now, the rodent coil, and the variation of the rodent coil that we're working with, it has the ability to induce power from coil to coil. So if you have two identical coils, or one could be a little smaller or one could be a little larger, it doesn't matter. If you put them on top of each other or below each other, they will transfer power through the field. And it has this remarkable ability to transfer energy very efficiently from coil to coil. You don't even have to have the same type of coil. You can have a different type of pickup coil, but if you have a different geometry, you do have to have a ferrite core to concentrate some of that energy. But these coils don't need a core. They're air core because simply, in my opinion, they utilize a different mechanism of action, which would be the field cavitation. They don't need a core to do this, to concentrate that energy. They're using the geometry to do that. So anyways, that's, I digress. What we're seeing here in the dual thief setup, though, which is utilizing 2 dual thieves, is something very remarkable. And I'm going to show a couple of videos. There's about 2 or 3 videos. Maybe I'll show the 4th one. But we're taking a modified dual thief with the vortex coil, hooking it up to a battery, and then we're taking another coil, hooking it up to another modified dual thief, but that one's not hooked up to the battery. And we're just taking that secondary coil and placing it on top of the primary while the primary is powered. And what we get when we combine the 2 outputs is a doubling of brightness on the output. So when we're powering this panel, this 40-watt panel, it doubled the brightness. And we're going to see that in this video. But while monitoring the battery drain, it was still at around like 20 millivolts per hour, 25 millivolts per hour drain on the battery. So it was still very, very slow drain. It was almost identical. So it wasn't really touching the battery at all. It still lasted the same amount of time with, 12.2 watt hours of energy. Alright guys, so I have the PCB version running, humming, singing so loudly, with the resonance relay on the positive, making it hum so loud, and the 40-watt panel is about 6.5% bright, very bright, compared to what it was without the resonance relay. And we have the dual thief. Look at that. The secondary coil, check this out. Tuning it not only produces voltage extra in the dual thief, but we also get extra voltage as indicated by the neon lamp here. So that's also interesting. So when we have this dual thief setup where we have a primary and then a secondary that's not hooked up to the battery, just sitting on top of the primary coil, so you just have two coils, one sitting on top of another. You hook both the outputs up together, and the LED panel increases brightness. But if you don't hook the outputs up together, it still indicates high voltage on both ends. So what you'll see is not only does the secondary coil excite the 60 volt neon lamp, that little neon lamp on the other one. Here, I'll rewind it a little bit. So this one, that's the secondary. So that takes at least 60 volts to excite that light and light it up. So it's picking up at least 60 volts from that coil. That's not touching the other coil's power source. And we know this because, why? The other light, which is basically a safety light. So when we have the lights hooked up to one output, the other one's not hooked up to we don't have both outputs hooked up on, I don't think, in this setup. At least not yet. So what we have, though, is this light actually turns on when the other one's in tune and picking up that high voltage as well. If it was a capacitance type thing where it was just taking extra energy from the primary coil, or if it was taking energy that wasn't extra from the primary coil, we would see a capacitance or a parasitic type of effect where if that light was on, it would turn off. But instead it turns on, indicating that it's actually enhancing the primary output even when it's not hooked up to the secondary output. So that's very interesting. That's all evidence that this coil is picking up extra energy and not putting a hindrance and just, you know, absorbing some of that energy from the primary coil. So when we hook up both of the outputs, what happens? As indicated by the neon lamp here in the primary. And here it's a lot louder. Okay, so let's take a look at the AC signal. So you have 65, 64 milliamps AC coming out of the battery. And let's detune that. Oh, look at that. It's like it's holding the charge a little bit. And look at that, 46 milliamps when it's out of tune. We'll tune it again. Hear that? 69 milliamps. All right, I plugged in while it was tuning, or in tune, the Dual Thief, plugged it in, and the lights went immediately dim, but it started humming a lot louder. Let's mess with this a little bit. Oh, there we go. Haha. Oh, shit, now it's back. So look at that. Okay, now I finally hooked up both of the outputs. And so look at that. So it was so dim you can kind of see the LED strips inside. The two strips, one on top, one on bottom. When it's fully bright, you can't tell because it's so bright you can barely look at it. A 40-watt panel is very bright. It's meant for like an office setting. It's actually, when it's 100% on, it's too bright for my lab because my lab's a little small. A little smaller than a traditional office setting. But look at how dim it is compared to when I tune the second circuit in this specific Dual Thief setup. Really dim, but it started humming a lot louder. Let's mess with this a little bit. And look at this. Oh, there we go. We get the high voltage indicator. Oh, shit. Now it's back to where it was. Look at that. 72 milliamps now on the draw. So it might be a little bit brighter. I think it might be a little bit brighter. It's hard to say without the lux meter. We'll take some lux readings in the next video. This is very cool. Very cool. Let's go all the way. If we all the way detune it, still 72. So technically this whole range is in tune, and then for the Dual Thief, and then detunes like that, and it goes, oh, it goes up. Wow, look at that. Or no, it goes down, sorry. Yeah, no, it went up. 83. It's a little unstable, that meter. You have to move it around a little bit to get an accurate reading sometimes. That means it's storing more energy. You don't want it to store the energy. You want it to gather the energy, store it for a second, and then discharge. So we discharge it now. Yeah, so again, I explained that humming in the coil as like the easiest way that I can describe it is, in my opinion, it's a resonance cascade, right? It's energy building up with nowhere to go. Even if you're dumping a little bit of it out and your coil's humming very loud, it just means your coil, in my opinion, is storing more energy than you would want it to store. Now, getting rid of that hum entirely, I don't think is possible. Like, you can still hear it if you put your ear very close to the coil in some of my highly efficient and tuned setups. It's not very loud, right? It's not something that's going to disturb you if you try to sleep next to it. You have to go real close, but you can still hear it. But it is an indicator, in my opinion, and from my direct observations and experimentation, of inefficiency, right? You can kind of gauge that the system's in resonance now, but it needs somewhere to dump this energy. You need to quiet that humming in order to reduce that resonance so it's not a cascading effect where it's just building up with nowhere to go. And also, you do hear that when it's detuned. Notice when I detune the secondary circuit on the Dual Thief in these videos, it's very loud. And then when I tune the secondary circuit, it gets very quiet. Now, the efficiency increases exponentially at that specific moment as well. So these two things, they could be, correlation. I'm not saying it is, but in my opinion, it could be. Some kind of effect where you need to dump that energy. If it's humming really loud, that means you have you have a lot of energy with nowhere to go. All right, here's the Dual Thief final edition before I have the test and go to sleep. I made one quick addition. I added another resonance relay, high-speed diode there, to the positive rail of the Dual Thief, the secondary pickup. And the voltage is at 12.65. We're gonna, flickering down to 12.64. We're going to monitor that overnight, see how slow or how fast it drains. Oh, this is a little, there we go. All right, and then we're going to do a quick AC check because it did go down slightly, 69, 70, or up. It was adjusted, I forget what it was originally, but without the resonance relay, I think it went down slightly on the battery. I think it was at 74 without the resonance relay, if I'm not mistaken. All right, voltage, again, it's 12 o'clock at night. We're gonna monitor that. It's at 12.65, going down to 12.64. The Dual Thief with two resonance relays, one on each of the positive output to the load. And it is humming really loud. All right, so did you catch that? This is how I have it hooked up. I have both the positives. So I basically have a positive negative output rail for the primary, right? The negative rail goes directly, is tied directly to the battery. The battery's negative terminal. So it's a ground. I have both the positives of both circuits hooked up. And then I have the ground of both of them hooked directly up to the battery, right? Where the standard Dual Thief ground goes. So that's all you do is tie in the positives together. And that's all I did was set one coil on top of one another and tie in the positives. Only one coil is hooked up to the battery. And spoiler alert, the battery lasted just as long as it did without it. So, dun dun dun. I think I have one more video we can show you. Okay, I have the dual thief set up with 2 resonance relays. And check this out. So it's detuned. Okay, so you hear it really, really loud. The coil is saturated. 65 milliamps coming right out of the negative from the PCB, which is very unusual because we're only measuring about 10 milliamps on the positive. So watch this though. 65 milliamps coming out of the negative from the PCB to the light source. And look what's coming out of the positive of the battery. 64, 65. Which is insane. Now watch this. So I'm gonna tune it. It gets brighter because we're using that energy instead of it just stored and saturating the coil. So check this out. So we tuned it like this, and look, it goes down to 48 on the draw of the battery, 45, 44. But not only that, look at this, the negative coming right out of the PCB to the load. 47. 47 milliamps coming out of the negative to the load. 46. And keep in mind, it's actively stepping up the voltage undeniably while doing this. We're monitoring the current, the AC current, and given the RMS problem that we've been discussing a lot on this channel, these, take these readings with a grain of salt. However, what system have you ever seen that can pick up kind of these measurements where the current is not just being maintained but being stepped up while the voltage is being stepped up as well? That is extremely unusual. At the very least, warrants further investigation. I mean, this is just more evidence. More evidence. 45. So we're getting about 2 milliamps extra on the negative rail to the load from the PCB. This is insane. Now, if you monitor the positive, we don't really get that. We get about 10, 11 milliamps. Crazy. It is. It's absolutely crazy. So for our final question for this section, what new possibilities emerged from these observations? Well, from the Joule thief, the possibility of a low energy output circuit that can sustain itself for extremely long extended periods of time was the real treasure. I mean, compared to any other standard off-the-shelf inverter, you're just not going to get this kind of runtime for your buck. You're not going to get this kind of bang for your buck. Using a 12-volt, 20-amp-hour battery, it's just not going to happen with another inverter. It doesn't matter what kind you buy. It proves that the system is doing something very unusual, even if the efficiency can't be accurately measured with standard methods. With that came an important new question, though. If we can't accurately measure this type of energy, how do we calculate an accurate COP for the system to actually prove its abilities? I mean, we have to prove it's doing what the theory says it's doing, right? Now, this became a real major issue for a long time with this model. But we eventually solved this issue by suggesting instantaneous power integration over time as an alternative method to capture these effects mathematically. Before we go into the next section, we're going to take a quick break. So while we do so, I want to emphasize people that if you haven't done so already, please hit the like button. It does help share this video and important information with more people on the internet. We are at a YouTube bottleneck regarding the algorithm. It doesn't seem to want to share my content unless you guys really interact. So really hit those buttons, interact with the content, leave comments, ask questions, use the little emoji button and the side of the chat that a lot of people just don't know exists. It's at the bottom right corner. It's a little arrow. You push it up, and there's a little bunch of emojis like a heart and different stuff that you can use. And all of those types of interactions, the algorithm takes those in and says, hey, this information is important. It should be shared. So interact with this content as much as possible, and that's the way that we share it on this platform. So we're going to transition into a quick break, a quick intermission, and when we come back, we're going to go over some of more observations based off of Daniel Nunez's systems and his work. So don't go anywhere. Remember to subscribe for more revolutionary content right here and only here on Beneficence TV's The Benefactor's Guide to Free Energy Devices.
Have you heard about this Benefactor guy? This dude is talking about free energy, but here's the twist. He says it's not free energy. He's calling it energy recycling, which first off is kind of genius, right? Because when you say free energy, people immediately throw you in the crazy bin. But energy recycling, that sounds like some next level Tesla shit.
Yeah, man, it's all about the branding. But what is it that he's actually doing?
All right, check this out. He posted this. Free energy isn't actually free. This is a misnomer. It's actually a mutual exchange from the vacuum, a field of energy from which everything arises, the same energy that powers an atom. Like what? Bro, that's some deep shit. But then he breaks it down. He says you can tap into this energy without breaking any known laws of physics by using something called back EMF capture.
Whoa, back EMF capture? Sounds like some serious sci-fi tech.
Dude, listen to this. He explains that when a coil collapses using a pulsed signal, the energy that would normally just get wasted, like just dissipate as heat, can actually be recycled. He says nature gives you back energy to stabilize the system, which makes sense if you think about how nature works. Like everything in nature is always trying to find balance, right?
So equilibrium, is that like how water always levels out or something? I'm trying to remember what Ms. Murphy said to me in 6th grade science all those years ago. What was that? Oh yeah, Elon, stop eating that glue and pay attention. Man, if only I had listened, I'd probably be the one inventing energy recycling instead of just talking about it.
Exactly. So he's saying that by intentionally destabilizing the system, collapsing the field, you actually get energy back as a kind of natural response. And here's where it gets wild. He compares it to pushing a swing. If you push at the right moment, you don't need to use a lot of energy and the swing gains momentum. But instead of a swing, he's using resonance to harness that extra energy without it becoming destructive. He says most traditional systems are like a surfer fighting against the current, while his method is like riding the wave to shore.
Dude, that's crazy. So he's basically saying the energy is already there. I just suck at using it efficiently?
That's what it sounds like. He's basically saying the way we harness energy now is like trying to swim against the tide. And if we used resonance instead, we'd be tapping into energy that's already there, just waiting to be used. I don't know, man. Either this guy is onto something or he's the most poetic bullshitter of all time.
Well, if he's legit, why isn't he all over the news? I haven't heard anything from him on X, formerly Twitter. He hasn't said anything bad about me on X. So, you know, I didn't ban him or anything. Look, I'm not the monster my therapist says I am. I mean, sure, I've spent millions of dollars training to beat a kangaroo in a fist fight, but that doesn't mean I'm dangerous. It just means I get shit done.
That's the real question, man. But here's the craziest part. I looked into him, and he's not selling anything. he open sources all of it. That's the real question, man. Either the system doesn't want to hear it, or we're about to find out if this guy disappears in the middle of the night.
Dude, that's crazy. He's absolutely crazy. That means if he's telling the truth, anybody could build this in their garage. You know what I say? Go fuck yourself, Benefactor.
Nope, no patents, no paywalls, just straight up, here, take it, see for yourself. Like, what kind of madman does that? Usually people, have you heard of...
You might have heard a Joule Thief circuit hum to you before, but have you ever heard a Joule Thief circuit actually sing to you? This is energy recycling. 15.5 hours of continuous power compared to just 2.5 hours off of a standard inverter. While this traditional inverter already maxes out at 88.5% efficiency, we're breaking every limit with my Vortex coil system. This standard DC to AC inverter will only run for 2.5 hours on 12.2 watt hours of energy. But my system provides energy for a whopping 15.5 hours off of the same 12.2 watt hours. That's over 6 times more efficient. Not only that, this system will keep powering my lights well past 12 volts on the battery. This isn't just an upgrade, it's a new industrial revolution. This is the energy of the future, and you are powering it. Imagine a world where energy is infinite, where the power to fuel our lives doesn't come from burning the past, but from harnessing the future. This is the breakthrough that changes everything. 0-point energy, the power of the universe itself, unlocked, and you are the reason it is possible. While the world sleeps, you're awake. While others talk, we are building. This isn't just technology, it's a revolution. And it's happening right now, powered by you. So thank you so much for joining me here on Beneficence TV and supporting our goals in open sourcing 0-point energy technology and disseminating all forms of forbidden knowledge.
Changing the system, treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice?
All right, welcome, and welcome back to the Benefactor's Guide to Free Energy Devices. As you can see, I hooked up my impulse driver circuit, and it is working beautifully. So, as we've been discussing, every investigation has a beginning. For me, that beginning was the work of Daniel Nunez of One Stop Energies. Now, his experiments presented an unexpected observation that deserved, or his experiments presented unexpected observations that deserved independent investigation. Before developing my own ideas, I first needed to determine whether those observations could be reproduced. And we did reproduce all of them. As many of them that I could attempt, we reproduced every claim that Daniel Nunez had made. One of these claims was particularly important to me, and I didn't immediately know why. I just knew that I needed to investigate this anomaly further. And that anomaly was the Wattman reduction test. So this was a really important experiment that Daniel Nunez had performed, and I'm still trying to find the archived footage. I've viewed it somewhere online, and I need to find it for you guys to show you, but it's basically a video where he spun a magnetic rotary, just a standard magnetic rotary with a it was like a little circular cylindrical plastic cap that he put on top of the coil that housed the rotary, and it was just a standard magnet that spun. Now, while spinning this magnet using what I assumed to be some kind of stereo amplifier method, Daniel in the video demonstrated a stable effect of 1 watt reduction of input power. So you have a Wattman meter. Actually, I have one right here I can show you guys. So you have this Wattman meter. It plugs into the wall, and then you plug in your device into the meter, and this meter monitors how much wattage you're consuming from the wall. And this input power reduced for Daniel Nunez by 1 watt. And I was like, that's really interesting. I wonder what kind of reduction, if any, we'll see with the neodymium sphere, because we have seen the videos where Daniel spun the sphere really fast. And I'm thinking to myself, let's try monitoring that to see if that has any similar effect. Because if you think about it, the neodymium sphere, it complements the geometry of the coil a lot better than a standard magnet. So, we experienced a 33 watt reduction of input power in our test using the neodymium sphere method, which is phenomenal. So going into the video that we're going to watch in a second, I want you to ask these questions to yourself. Why do you think the original Nunez experiment stood out? Could these results actually be reproduced? And was the wattage reduction an actual reduction? Was it a real effect, or just some surface level charge effect? And if it was a real effect, what mechanism can explain it? So I'm going to pull up the video. Alright everybody, here's something really cool. We have the stereo method hooked up right now. Okay, 10 volts from our power supply at 140 milliamps. Okay, we're gonna spin this little neodymium magnet,
and we're going to monitor the wattage, okay? Oh, it's not going to show it. Oh, you got to show it. There we go. Okay. So, 7.3 because we don't have it on. We're going to turn it up. Check this out. Okay, let me take that. We're going to take the magnet out first. Okay, we're going to turn it on. I'm turning it up. Look at the watt consumption. 24 watts, okay? Now watch this. We're gonna put the neodymium magnet in there, spin it up, increase the frequency. Now check this out. Wow. And it goes back up, 24. We saved 10 watts of power by spinning this thing. Holy crap.
So yes, holy crap is right. That's extremely important result right there, because going into this, I had a reluctance of putting that volume knob on the stereo amp we were using to drive the sphere all the way up to 100%. So when it's at 100%, it consumes 40 watts of power. Now, we were at, I think, about 50 or something like that on the knob. When turning that all the way up, that 14 watts goes up to 33 watts in reduction of input power. So that is very, very significant. Now this experiment stood out to me because I said to myself, if we could get 1 watt reduction with a standard rotary, what happens if we introduce a faster arrangement? And the second question was, could these results be reproduced? And yes, we did reproduce them many times on live stream. Specifically, we saw a 33 watt reduction. The maximum input reduction we saw was around 33 watts when the volume knob was all the way up and the sphere was fully synchronized with the system. Now, the most important question, though, was this reduction real? And at first, we didn't know. I had no idea if this was just like some kind of surface level trick. Maybe I didn't know enough about, electromagnetic phenomenon to understand the system and what was happening. So we ran a further experiment that kind of gave more evidence to what was going on. Specifically, I said, okay, so if we have this hooked up to a wall and a power supply, what happens when we hook it up to a battery? Now, I thought to myself, if we are getting that kind of reduction in input, that amount, it theoretically should produce some kind of unique effect with the voltage, right? Either the voltage is just going to stay at a certain, shelf, or maybe even go up. And it did. It went up. Spoiler alert. So yes, absolutely. Any surface level charge effect like this would not be stable and reliant on the spinning of a magnet. And this is going to go into the battery reversal under load. We're going to watch that video in a second, but just so you guys have full context, once the magnet spins and is fully synchronized with the system, the battery voltage... So before... let me back up. when you start spinning the neodymium magnet inside the coil with this setup, the battery voltage immediately jumps to a higher shelf, indicating the system is trying to draw less from the source, from the battery, without the magnet spinning. Before it synchronizes, it does draw a little bit of battery, and it goes down, the voltage, like a system should. But once that magnet starts spinning fast enough, at a fast enough RPM, I suspect that could be a subharmonic of the system's resonant frequency. Once it starts spinning really fast and synchronizing with the collapse event of the coil, the battery starts to climb. And the climb is very steady and stable, and immediately drops the second the sphere desynchronizes from the coil, or you take the magnet away. You can audibly hear when the magnet desynchronizes with the coil. It sounds like it's trying to catch itself. It's not a smooth rotation. So, going back to the original point, though, we would never get a stable climb of voltage reversal with a surface level effect, let alone that climb being dependent on a spinning of a magnet. So those two characteristics, one being dependent on one another, specifically indicates that the magnet itself is recycling energy in some way. So it's kind of like my new idea that this setup might essentially act as a sort of hybrid between the Bedini SSG and the Rodin coiled systems, specifically because when you're spinning that neodymium sphere in the coil, you're creating the back EMF component needed to recycle the energy that Bedini uses. I believe it is basically the same system as the Bedini SSG, but with one battery instead of two, meaning you spin the magnetic rotary, and that's pulling and shaping the energy in a way that the battery will accept and return. So that's the only way that I can kind of conceptualize it in my head, at least. Because what the Bedini SSG is doing is it's essentially spinning a magnetic rotary, creating a collapse event, inductive spike, and the arrangement of the magnets, which ironically, I don't think it's so ironic though, I think it's intentional that he called this arrangement a monopole. And we're going to go into this in a minute, but monopole is one of the fingerprints of synthetic AC. So, or at least the field cavitation present in the synthetic AC model. I'm not saying field cavitation might be occurring in other systems outside utilizing synthesized alternating current, right? You might have other types of systems that don't have synthesized AC that have field cavitation. We might, I wouldn't be surprised one day discover that is something that's actually happening with other systems, specifically systems that claim to pull energy from the vacuum or free energy type devices. But I just find it very, very interesting that Bedini himself described his magnetic arrangement of his rotary a monopole, because that is the fingerprint of field cavitation in our theory. So you see these overlying patterns. And really the only difference in this setup has from the Bedini SSG is, it's feeding that output back into the input. It's not feeding that output, that spike, back into a charge battery. So in a traditional Bedini setup, you have two batteries. You have a trigger battery that runs the circuit and triggers the collapse of the coil and the inductive spike, and that spike goes into a secondary battery. So with this setup that we're about to see, it's one battery. And, as I've been talking about, the mechanism which might explain it is field cavitation theory. It is the only mechanism that I've been able to find that explains all of these unique effects that happen in these types of vortex coil systems, and specifically the effects that the Rodin coil is known to produce. Vortex-based math theory says that these effects should be present, but regarding an actual underlying mechanism of action that we can relate to in physics as engineers, we need something less abstract. We need something concrete, something that explain these unique phenomenon in a way that we can understand them as engineers. That's where the synthetic AC model comes into play. It's kind of like a bridge between the abstract nature of vortex-based math and, standard electrical engineering principles. So field cavitation theory is, in my opinion, what is the mechanism behind some of these unique phenomena in the coil. And this even includes the magnetic monopole. So we're going to get into that in a minute. But right now we're concentrating on the battery reversal under load, because this became one of the most surprising observations of the entire project. It directly challenged my expectations of how the battery should behave. I expected something crazy to happen or unique to happen with the battery, but to be honest, I flipped out when I saw the battery reverse its, charge. It's not something you see every day. It's not something you expect to happen. As much as you, as much as you build a theory that leads to that inevitable outcome, in the back of your mind, you always doubt it. You're like, there's no way it's going to go up. There's no way it's going to go up. So you just don't even think about it. And when it happened, I just flipped out. I was like, wow, this is crazy. So we're going to watch that video. It is direct evidence. And honestly, it's the only evidence that I've ever seen online that is evidence that points to the potential for a self-sustaining system. A system that is just unaffected by the weight that it carries. Really, the only way I can describe this is by contrasting it with how we describe free energy devices as being perpetual motion machines. And perpetual motion is kind of like a misnomer when it concerns these kinds of devices. It's really a pejorative. It's used to discredit and attack these devices, saying, oh, this thing is a perpetual motion machine. No, it's a self-sustaining system. That's not saying it's going to last forever. It's not perpetual. It's just a system that is basically weightless. And what it does is not going to last forever. Parts and bearings inevitably wear out. The actual tolerance for perpetual motion, assuming you have the ability to have a system that outputs say 200%, 250%, enough to feed back into itself, power something, and sustain itself. The tolerance for absolute perpetual sustenance in that system is astronomically impractical, right? Bearings are going to wear out, parts are going to wear down, there's oxidization in the components and the wires, and even if you have the tolerances up at maximum 100%, or I'm sorry, at their lowest 0%. Even if you have your tolerances down to 0, it's not going to be practical, right? It's going to be extremely, extremely difficult to reach that level of a self-sustaining system. So we describe them more accurately as self-sustaining systems instead of perpetual motion, because let's face it, perpetual motion is just at this point used as a straw man, right? It's used as a logical fallacy to attack something that most people just don't understand and label as pseudoscience. But when you're in a lab and you're experimenting with these kinds of systems, these nonlinear open systems, something unique is happening and you need a way to describe it. And the synthetic AC model gives us some of that terminology. It sheds some light on some of these effects in a way that's digestible for the average engineer. Here's the mini board. We're going to put a frequency from the generator on the laptop into the board and spin the sphere up inside this container and hopefully get this to actually increase. Let's see, we have the buck boost converter here, negatively conditioned battery on the third cycle. It is at 13.23 volts. So I think it's about time we start. Interesting. Oh, here we go. All right, tune it up. We're at 74 hertz, and it is not climbing. We are losing power. Interesting. Oh, you hear it? Let's try to tune it up again. 80 hertz. Oh, it's climbing. It's climbing. There you go. You can hear it's I think it's going to desynchronize. Yeah. You hear it? It got a little slower. Interesting. And watch 12.57 take it out. Oh, it's still spinning. It just stops. So it jumps down to a lower shelf. It's at 12.51 now. Let's go back down and tune it up, see if we can get it to go higher. .83 hertz. It is climbing. .7. Wow. It's climbing quite a bit. Come on, baby. Interesting. I'm just going to let it play out and see what happens. Wow, it's still climbing. Should I increase the frequency slightly? I don't know. I don't think I should touch it. It's at 84 hertz, 83 hertz. Yeah, I went back down. It's desynced. Let's try it one more time. Oh, here it's as long as it's spinning. I put it back down and it's going up. So I pushed it in the center a little bit. It went up a little bit. That's interesting. Let's try to do it one more time with that a little bit more in the center. 6. See if we can get it a little bit higher this time, maybe 90. .92. Alright, let's push it down in there. Yep, it's going up. Oh wow, It's already at 12.79. I have to hold it in there. Hold it in there a little bit. It's going up. Yep, that's all I had to do is hold it closer to the center, the equatorial plane. We were like probably a little bit outside of the null zone. We want that null zone because that gives us the monopole. In its cleanest form, I guess, with the sphere, the synchronized. It's still going up. I just heard it catch. For the first time, I just heard it catch. So it could be going down now. No, I'm trying to push it more in there in the center. Still going up. One more time without the buck boost converter as well. Try it one more time without the converter. It's still going up though. Let me take a temperature reading of the battery. Battery's still cool. It's about ambient 67, 69, 70. Terminals about the same. I mean, it's spinning pretty steady. Let's take this magnet out. We're taking the magnet out now. Notice how the voltage drops. It's still spinning, by the way. Still spinning. Outside here. Wow, wow, wow. Okay, violent. Look how it drops. All the way to 12.57 now, and dropping really fast without that sphere. Look, it just keeps going. It'll just keep going. Because it's drawing power, obviously. This magnet was fucking putting power back into the battery. Indefinitely. Alright, so we're gonna turn that off. Absolutely incredible. So this all led to the discovery of the synthetic AC model. And these systems became the linchpin, the turning point of the entire investigation. The oscilloscope displayed an alternating electrical behavior that wasn't conventional AC and wasn't ordinary pulsed DC for sure. Instead, it appeared as though the forward pulse and the inductive collapse pulse were combining into a single oscillating electrical system, a single unified resonance system. And actually, now that I think about it, we were going to go over the 3 characteristics of the resonant pulsed waveform. In the video, I kind of go over it, but it was a little confusing because it went back and forth. So let me lay it all out for you right now, because I intended to back during that video and I completely forgot. So the 3 defining characteristics, or rather the 4, you decide if it's 3 or 4, but the 3 defining characteristics are On the default scale of our oscilloscope with a floating probe, we get all those nested harmonics, like secondary and tertiary squiggly lines. But we pause it and it's one single line bouncing off of itself in a very chaotic manner, it looks like. We zoom in and we get that identifying sort of 0-point convergence point where you see this major sideband activity and basically nothing in the middle. The third characteristic is on the macro scale, zooming all the way out on the oscilloscope, we see all of that nested chaos converge into a smooth sine wave, or albeit somewhat smooth, when you consider the overall structure. What's going on, Steven? How you doing? Thanks for joining us today. Hey, John Gray. Thanks for the thumbs up. Appreciate it, buddy. So when you see those three defining characteristics, there's a fourth, which is no matter where you probe the system with a floating probe, you will find those three defining characteristics. And that's the fourth defining characteristic specifically for the resonant pulsed waveform. No matter where you probe it on the system, you probe it on the coil output, you probe it on the system output, the circuit output, between the circuit and the coil, you probe it on the input of the system, on the battery, and it produces those same three characteristics. So you decide if it's three characteristics or four defining characteristics. I couldn't decide, but that's what we see. So going into field cavitation theory, which is my favorite part of the entire model because it explains everything so well, it gives us a clear picture of why the system is able to do all of the cool things it's able to do. Now, up until this point, we focused almost entirely on observation. We've been seeing unexpected waveform behavior, battery reversal under active load, energy recycling, evidence of energy recycling, and evidence suggesting that the forward electromotive force and the back EMF might be interacting in ways that conventional pulse circuits simply don't exploit. But observations alone aren't enough. Every scientific model eventually has to answer one difficult question. What physical mechanism could actually be producing these effects? The synthetic AC model proposes that the answer may lie in something that I call field cavitation theory. I wonder if I can pull up a diagram for you guys. That'll help facilitate the visual, or a visual to help facilitate the learning. Let me see if I can pull it up. Oh, there it is. Okay, first I'm going to pull up an image of bubble cavitation in fluid. Okay, this is an image of bubble cavitation in fluid. Notice the similarities right away between the geometry of the cavitation bubble and the geometry of the coil. This is very important. Geometry in our model is the primary factor, right? The shape of the field is more important than the shape of the circuit, at least in regarding the synthetic AC model, regarding that context. So let us pull up. Hey, Jamie, pull up that presentation image. Yeah, like I have a fucking editor. Okay, so this is field cavitation. We're going to put that right there so you guys can look at it while I talk about it. So in field cavitation theory, rather than viewing magnetic fields as static objects that, simply appear and disappear, field cavitation proposes that under the proper geometry and timing, the electromagnetic field itself undergoes a rapid collapse that creates a temporary region of disequilibrium, a void, a vacuum rather. And what does nature abhor? Nature abhors a vacuum. Always hates a vacuum, and that's why the collapse of the cavitation bubble in fluid is so violent. All that water rushes in to fill that vacuum. Now, for cavitating the field, something's rushing in. It could be stray electrons and free ions from the environment. Just pulling those in and reorganizing them into the system itself gives us a mechanism of action that explains over unity. That in and of itself. So this disequilibrium may allow two normally independent electromagnetic events, the two channels separated in one bundle of wire, seen in our coil setup, may allow them to interact through what I've described as a field bridge, a bridge between the forward and backward pulse, where you have a small, tiny sliver of a gap, but one is chasing the other, kind of like a surfer riding a wave instead of fighting against the current. So if such a process really exists, then it shouldn't merely explain... It shouldn't merely just explain synthetic AC. It should leave behind a measurable fingerprint elsewhere in the system. So we should have some way of seeing if field cavitation is happening, whether it's directly or indirectly, through its direct effects or through its side effects. And that's where we come up with that's where the magnetic monopole evidence comes into play. This is very important because a lot of people have picked up a magnetic monopole in these systems, but they don't really, or haven't really answered the question, why is this monopole in the system? Like, why are these coils producing a monopole when standard coils can't? It's not something that traditional science even accepts as possible. Maybe under highly theoretical models, when you're talking about like Lieutenant Tom Bearden's, asymmetric regauging principles. Outside of that, though, it's not really a concept. So when we see a magnetic monopole in these systems, it has to be evidence of something, right? But what is happening that's causing that monopole? So this theory of field cavitation explains not just the monopole fingerprint, but is evidence that the field cavitation is actually happening. So if field cavitation is the real physical process, then it shouldn't only affect voltage and current, right? It should also alter the magnetic field itself when you think about it. One of the most interesting observations through this entire investigation has been the evidence suggesting the formation of what appears to be a magnetic monopole, or what I call a pseudo-monopole, because it's not a true monopole in the natural sense, but a synthesized monopole. So I'm not claiming we've discovered a fundamental elementary particle or anything like that. Rather, I'm asking whether the geometry of the Rodin coil itself allows the magnetic field to organize itself in a way that temporarily exhibits monopole-like behavior. If this phenomenon is observed, it provides an independent line of evidence supporting field cavitation. And I'll show you the video where we actually do pick up the monopole. But by shaping counter-rotating fields, by shaping them to enforce a central spatial void, using compression and rarefaction with the timing and geometry of our system, the geometry theoretically should compress one pole from each field. If you think about it, look at the image. All right, this is an exact visual of what's actually happening. Only the two fields are represented on occupying different space, just to give you an idea. But in reality, the compression and rarefaction field are occupying the same identical space. So they're just separated in this image, just to give you an idea that they're two separate things, because you don't want to overlay them on top of one another when you're trying to relay that idea. And also it gives us a clear image of the 0 point, the null zone in the center, the equatorial plane. But you imagine these two fields occupying the same space. They're not separated like you see them in the diagram. That's just to facilitate the learning of to grasp the concept. So let me take that down a little bit. There we go. All right, so by shaping counter-rotating fields to enforce a central spatial null zone, you know, that theoretically we should see the geometry compress one pole from each field, leaving behind what? A detectable monopole signature. And this, you know, thus is the defining fingerprint of field cavitation, in my opinion, at least based on our model. So let's look at the video because it's really cool video. But again, I'm not the first person who's seen the magnetic monopole in these systems. We're gonna put I have only replicated this. Daniel Nunes saw it. I believe Jack Scholes in his experiments saw it. You know, a lot of people who did these experiments saw the magnetic monopole. It's not something that we discovered here specifically. What it is, though, is a fingerprint that kind of gives more evidence to support field cavitation theory, along with other aspects of the model. Where is it? Oh, there it is. Variation or a different threshold, right? So there's a threshold for like maximum field cavitation. It's a spectrum, really. It's like, it's not that it's either happening or not happening. It's not binary. That's the most interesting thing that I found here, is that if it's happening, it's on a spectrum, right? You see at different frequencies, and this is in my do-it-yourself guide, you know, a caveat in the guide for the monopole test, if you're replicating it, is you hold that button down for as long as possible, because at certain frequencies, it'll blink, you know, like south, 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 and it'll blink like that for a while, and then all of a sudden it'll pop up one north. So it's not a true monopole frequency. It's close, but no cigar. But this is still evidence that the field cavitation is happening, just on a different level, a different degree. Perhaps not at its maximum saturation level or, you know, energy density potential, whatever the case may be, there are variations that you have to be aware of. So you could think you're at a specific monopole frequency, but you hold that button down for a couple seconds longer and you might see another pole pop up. So just be aware. I, as a standard rule of thumb, would hold it down for at least 60 seconds. I know it's a long time, but at least 30 to 60 seconds is the time that I would use. I haven't really seen a north pole pop up outside of like that window. However, I'm not saying it's not possible. Just, you know, in my setups, I haven't really experienced that. So I use that as kind of like the window for finding the monopole frequency. But yeah, it's really, really cool, really interesting, because we see this as not a binary process, but as a process that kind of slowly happens at a lower threshold and then builds into a maximum kind of like potential. And, you know, that makes sense. You know, if the timing is off, which, you know, the frequency is all the time, you know, the frequency dictates the timing. So if the timing is off a little bit, then the fields aren't going to overlap in a way that compresses both one pole from each field successfully, right? One's going to leak through. And that's exactly what we see. And now we understand why. Like, we finally have some kind of reason behind some of these weird things that happen with the coil. Up until now, people were just like, hey, this is cool anomaly, you know, like, but like when you look at the deeper layer of it, field cavitation really is the ultimate answer as to, you know, what the hell is happening here on a, you know, a physics level, right? If you look at the electrodynamics of the system. So going back into the three characteristics of synthetic AC, the synthetic AC's resonant pulsed waveform that we picked up. I mean, they can use, one might be dismissed as coincidence, but repeatedly observing the same characteristics across all areas of the circuit suggests something is more intentional that's happening here. Something system-wide is happening, some kind of system-wide resonance. Throughout this research, though, the oscilloscope that I've been using became the primary investigative tool. It really opened up all of this kind of understanding of what's going on. Without that high-speed oscilloscope, I wouldn't have picked up the resonant pulse waveform. I wouldn't have found evidence to suggest that, there's a kind of synergy happening between the two energy components, the two pulses, that produces like this smooth transfer of energy on a large enough scale when you zoom out. Like, seeing that was mind-blowing, because the more I thought about it, the more I'm like, wow, this is everything you would expect to see in a system if these markers of synthetic AC are actually there. So while multimeters reveal averages, right, the oscilloscope reveals timing, polarity, phase relationship, phase angles, and transient events that would otherwise remain hidden. And a lot of older model oscilloscopes simply wouldn't pick up these effects. I'm gonna tell you right now, they're not gonna look like this. Simply because this has a really, really high refresh rate, and older model oscilloscopes are a lot slower. This fast oscilloscope has trouble keeping up with the speed of the frequency of the coil, let alone an older model. I can imagine there would be all sorts of visual anomalies that would distort these three characteristics. So without this oscilloscope, I never would have seen these effects without, with just standard tools, multimeter, using root mean square and all that. Or, a standard oscilloscope that wasn't a high-speed oscilloscope. Some, cheap tool. I really needed to invest in a expensive piece of equipment here. Because without this oscilloscope, none of this really would have been possible. And this is partially why I pivoted to measuring this energy, though, as instantaneous power integration using joules instead of root mean square, which is commonly used by engineers to gauge efficiency in your system, right? You're expecting to measure an average amount of power that's coming into your system because it's a continuous flow back and forth, reversing polarity back and forth. But these are pulse systems. They're using very fast impulses to transfer the energy. That's a different way of transferring the energy that requires a different way of looking at the power transfer and how to calculate it. Root mean square just isn't going to do it, which explains why a lot of investigators and researchers before me failed to capture the true efficiency of these systems, even though they were producing remarkable effects, lights lasting way longer than they should on a battery, compared to a normal system. But you can't pick it up. So this is an explanation from that. I mean, John Bedini even warned us, you can't pick up this energy with a standard meter. It's just not going to work. So let's take a look at energy partitioning. Actually, should we take a break? Let me see how much left we have of the presentation. I might take a quick break again. Yeah, we're going to take a quick commercial break. And when we come back, we'll go into evidence of the energy partitioning part of the synthetic AC model. So we'll look at some of the evidence that shows us, that indicates the system is actually partitioning energy, separating the forward and the backward components and utilizing them for separate purposes. So don't forget to hit that like button and subscribe for more revolutionary content only here on Beneficence TV. And you're tuned into the Benefactor's Guide to Free Energy Devices. We'll be right back.
In a world where innovation is stifled by greed and corruption, there lies a hidden truth that could revolutionize our way of life.
Lenny, what are you doing? Are you seriously pitching a new show right now? I didn't authorize this. My God, only 5 minutes into your new position as co-host, and you're already adding to my tight schedule.
Yes, sir. I manage that schedule. But I did notice you have an entire 2 days available during your week.
Wait, you're not talking about Saturday and Sunday, are you?
Of course, sir. You have 2 whole days where you're free to work on new content.
Lenny, those are my days off.
It's okay, sir. I know you'll manage just fine. I have faith in you.
Do robots have faith?
I do. I have faith that you won't screw it up again.
You know what? It's fine. Go ahead. I'll just build my cold fusion Lego set some other time.
It's pond certified.
But I'm not telling them about my idea for a thunderstorm toilet. I'm gonna keep that baby close to my chest.
You know, that just sounds wrong.
It's a good idea. A toilet capable of turning any toxic human waste into, well, it turns into petroleum jelly.
Why petroleum jelly, sir?
You know what? I'm not sure. I don't think it's calibrated correctly.
Enough is enough. The world is at a breaking point. Catastrophic climate change, biosphere collapse, and a global energy crisis have been met with apathy, denial, and despair. The phrase unidentified flying object is a deliberately obfuscating term. What it really is an alternative energy and propulsion device. This is the real reason for the secrecy. These technologies, if they were disclosed, would end fossil fuels, pollution, and poverty overnight, and usher in a new era of abundance, freedom, and peace. Instead, they have been kept secret for over 100 years.
The more powerful the agency, the more powerful the group, the more powerful the cartel, the more they will resort not only to legal means, but to extra legal means to suppress their competition.
Hey, Mike. I'm trying to type it in the chat, and it changed to, hey, my dear? Like, what? On my end, it says, hey, my dear. What the fuck?
Not get suppressed, because what's
That is so weird.
Microscopic ball lightnings that when they discharge are tapping into that zero-point energy field and creating the motive force.
Oh, that's why the concussion from the thunderclap is so huge. There's this huge amount of energy. It's actually sourced from the vacuum energy. All the dots connected. This is what's happening, right? So we need to make the thunderclap engine.
Imagine a future where clean, sustainable energy is not just a dream, but a reality. Discover the countless untold stories of free energy devices and the relentless battle against those who seek to suppress them for their own gain.
Black shelving. So someone comes along, they offer you $20 million for your device. It's a corporation. They put it on a shelf. Boom.
This power is something I have given my life for you, the people.
Uncover the shocking tactics used by energy industries to control the narrative and maintain their grip on power.
You don't interfere with the big, powerful people. You don't put them out of business. They still have those 15-year leases on the lines and on the power transformers.
Environmental Protection Agency is a bit of a dictatorial police agency.
Shadowy government with its own Air Force, its own Navy, its own fundraising mechanism, and the ability to pursue its own ideas of the national interest, free from all checks and balances, and free from the law itself.
This is real, usable power. It's stable. It is not transient. It is not noise. Behind the lens, that little box is putting out all of that power, well over 500 watts, and yet it is receiving less than 1/3 of a milliwatt of input power. The rest of that power is coming out of the surging energy of the vacuum. And this little box that you see right here, solid state, no moving parts, is the vacuum triode that's doing this very practical and historical work.
But indeed, it put out more energy than it took in.
He was shot at once with a silenced rifle from about 300 yards. It reads like a James Bond movie, but it's real.
There are men here that said they're FBI, and they got black vans, and they're taking all this equipment. What should I do?
It's called capture, where they try to rationalize away this problem and everything's fine.
From manipulation of patent authorities to infiltration of government agencies, the truth is stranger than fiction. But amidst the darkness, a glimmer of hope emerges in the form of renegade scientists and inventors who refuse to be silenced.
There is absolutely no question that T. Henry Morey had a system that produced about 50 kilowatts out of a 55-pound box.
In the shadows of capitalism's dark secrets, join us on a thrilling new show. Get ready to be inspired, enraged, and empowered as we delve into the Benefactor's Guide to Free Energy Devices.
Only on Beneficence TV.
Yeah, Steven, it's like changing my... I don't know. Do you guys see? I wrote, hey, Mike, with a wave. So right under... in the chat, if you look right under Steven Drysdale, Steven says, you can figure out what I mean if you draw it out with a pencil. And then right under there, I wrote, hey, Mike, with a wave emoji, just saying, hey, Mike. And it changed to some kind of Japanese character, hey, my dear, and the wave emoji. I'm like, what the fuck? And then I tried doing it again, and it changed to a Japanese symbol, hey, soft, exclamation point. I'm like, what is going on here? Oh my God. It's like, is it like an auto censor thing and it's fucking up? Or is this like a malicious thing? I don't understand. Or maybe it's just appearing on my end and it's not appearing on your guys' end. I have no idea, but this is weird. This is weird. I don't like it. It's kind of disturbing me. Okay, we're going to be back in about 5 minutes.
This video was bang on brilliant stuff. I'll give it a shout out in my next video.
A man named Michael with a vision to show. Building towards the goal, he's got the spark, dreaming of a future that'll light up the dark. But on the other side, Bill Nye's on the rise with his lab coat charts. He's cut down all the lies, and it just fits. It's all in the map. You can't pull from the ether, you're just chasing a path. But oh, Michael's rising like a morning sun. With the power of ether, he won't be outdone. Now stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. In the heart of the lab, the tension was thick. Skeptics gathered round the table ready to pick. Show fruit, but neck, the case clear, and I find the stream, or just chasing a spin. But Michael smiled by with fire in his eyes. Watch as I spin, let the naysayers cry. Draw spin fast, and a heart full of fight. I'll show you the power that's hidden inside. Oh, Michael's rising like the morning sun. With the power of ether, he won't be outdone. Well, stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. Can't prove your theory, it's just not right. Go spin back, Michael.
the best there's ever been.
And in the depths of shadowed halls, I wandered all alone, casting whispers, binding chains, demons of my own. Toxic deafening, down spread on my frail soul. I once filled my mirror, haunted by my role. But in the echoes of my cries, just still I emerge, guiding me to where my true is observed. Now I rise from the shadows with wings of fire and sand, free from the chains of sorrow, all these paths of forever depend. Shattered glass beneath my feet, scars I wear but dry. Stormy nights has turned to dawn, where truth as my guide. Anxiety's dissolved in the sun's golden ray. I see my destiny through time and space. The fears that once consumed me now they take. For in my heart a new word is proclaimed. Now I rise from the shadows with wings of fire and sand, free from the chains of sorrow, on this path of forever depend. With symmetry, I found the power. Blessings granted by the hour. Together we will come the way. Revolution calls and I'm not strong. Now I rise from the shadows with wings of fire and sand, free from the chains of sorrow, on this path of forever depend.
Alright, welcome back to the Benefactor's Guide to Free Energy Devices. I'm your host, the Benefactor. Having a bit of an issue with the chat there. I don't know if it's filtering chats and changing them. That would be scary, but something is changing my chat input into the live chat, so kind of worrying. I don't know if this is something new with YouTube, where it's like censoring and automatically changing somebody's input, or something unique to my experience, but kind of disturbing. Anyways, yeah, Mike. Yeah. Anyways, we're going to jump into energy partitioning evidence. So this is evidence of energy actually partitioning in our system, which is part of the synthetic AC model and Tom Bearden's asymmetric regauging principles. So what happened when I was discovering some of these anomalies and measuring them kind of challenged my assumptions on how electrical energy was distributed throughout the circuit. I had to really change my perspective and go back to first principle thinking, because we see evidence of energy partitioning playing out as an asymmetric output of voltage on our lightning thief system, the modified joule thief with the vortex coil. So we see specifically 10 volts positive, and on the same output simultaneously we get negative 168 volts. This, in my opinion, is direct evidence of energy partitioning happening successfully in the system, because under normal circumstances, this should blow up your components. It should fry your components and overall just not run. And if it does, it's not going to be efficient, because this indicates that a whole bunch of heat and extra waste is happening. But we don't get that heat. We don't get that waste. Remember, the forward and the backward components are dancing with one another. They're not fighting each other like in traditional systems. So our system does the opposite. It runs extremely efficiency with this type of asymmetric output. But why? Well, the synthetic AC model explains it perfectly. When you have both components, the forward and the backward, in sync and dancing with one another, they don't fight each other. There's no resistance between the two events. They are, in that sense, self-reinforcing. This leads to a self-sustaining system unaffected by the weight that it carries, meaning it has the potential to achieve over unity. And with this new COP formula adjusted for this type of open system, we now, for the first time, have a mathematical framework to prove it if it is happening. Now, I'm not claiming over unity as of yet. I'm saying, though, we have the mathematical framework to prove it if it is happening. The only thing holding me back at this point is a high-speed current probe, which is, I think it's around like $200 or $300 online for my oscilloscope. So until we can invest in one of those bad boys, we really can't do the calculations for the instantaneous power integration using joules. But we have the mathematical framework to proceed. If it is getting a COP greater than 1, this mathematical framework should indefinitely prove it, because it's taking two independent thermodynamic events and adjusting them as one. So we have to understand that the system, all this evidence leads to kind of like a, not just a standard LC circuit, right? We have system-wide resonance. So what happens when we try to rectify this using a full bridge rectifier or something like a standard component? You know, we want to rectify it back into DC and dump it back into something. What happens when we do this? Well, at least in my tests, in my testing with this system, the specific joule thief system, it is not possible with a full bridge rectifier. You really have, you're really doing the rectification just with a single diode. You don't need 4 diodes to produce a full bridge. So some of the quickest ways to understand a phenomenon is to remove one variable or another and then observe what changes. This kind of subtractive observation is what led me to believe that these forward and backward components are really synergized in a way that traditional systems just don't know how to handle. And what I mean by that is if you apply traditional engineering thinking like, oh, a full bridge rectifier should, in theory, rectify this energy and back to DC and, be able to dump it into a cap bank and be usable again. But in my experience, it just literally destroys the output. There is literally no significant output. I might have gotten a little bit of voltage step up with the full bridge rectifier, but nothing that would be able to power anything significantly. Maybe a tiny LED bulb. And this is important because when looking at the model and how the energy is actually transferring, it's building a field bridge between the two components. And if you rectify that out with a full bridge rectifier, you're essentially destroying that that effect. At least in my observations, there was no usable output from a full bridge rectifier. Now I had to go back to thinking like, why is this? It turns out we were overlooking one of the most important aspects of the system, the diode on the positive output rail. This acts as a single component rectifier in and of itself. This does what you need it to do, essentially blocking one path and reinforcing another. So knowing that the single diode on the output already rectifies the energy, going forward, we want to use single diode components on different aspects of the system instead of, using something like a full bridge rectifier and a cap bank. Now, that's not to say that maybe there isn't a method to do it with the system, but I haven't seen any observable output indicating that rectifying this back into DC is going to be usable. And that in of itself is indication to me that there is some kind of synergy happening that, is a careful choreography. And you have to utilize that choreography in a very specific way, or else the effect just disappears. Now, this brings us into the resonance relay. That's what the resonance relay is. It is a single high-speed diode. And I used Arduino jumper cables, specifically the female ones, so that I can actually utilize this component and plug it in and put it where I want. So it's I build these systems so they're plug and play. I can plug in this component here and plug in that component there without having to solder it. And then when I have it all tuned and efficient, then we can move on to the permanent soldering phase. But when I'm testing these systems, I use something called the resonance relay. And we've had a couple of variations of this over the years. But this one was particularly important. Every discovery naturally led to another question. The resonance relay became the next logical step in continuing this line of investigation. High-speed diodes are essential in a system like this. John Bedini would emphasize the need for them constantly, but why? Well, at least in our system, the relay essentially acts as a single component rectifier. For the synergized energy, right? The diode allows the interaction of the field components, but it rectifies the current. It allows one component to flow to the output and the other to flow towards the battery for recycling. So it basically blocks the back EMF from going to the load and goes back into the coil and into the battery's positive terminal. Now, we noticed that by decreasing the reverse recovery in our component, the diode, by upgrading the resonance relay to its 2.0 version using the RHRP8120 instead of the UF4007 diode, this new resonance relay 2.0 with the higher speed diode gave us a lot more visual output visual brightness. Now, I don't think it necessarily doubled the efficiency. Maybe it did, maybe it didn't, but at least visually it doubled the brightness. So that's important, because why is there a difference between those two diodes? Well, the reverse recovery for the UF4007 is around 75 nanoseconds. And in the realm of impulse technology, this is an absolute lifetime. This is way too big of a window to allow leakage. We want to minimize that. And specifically, the RHRP8120 has about a 25 nanosecond reverse recovery, so significantly faster gate speed. So that's very, very significant for our systems. Now, we've been testing with this diode, the Resonance Relay 2.0, for all of our systems now. I haven't found a better diode to use. I tried a Schottky. We're going to try more Schottky diodes in the future. There might be a chance where we can get a Schottky diode to perform as well. It does work, but it doesn't seem to be as bright. So the specific Schottky diode that I ordered, but it might have a larger, I think it has a larger forward drop voltage, meaning it drops a little bit of the forward voltage. So that might be why we're seeing a slight decrease on the brightness. Not that it's performing like it's supposed to. I mean, it should be, but we're going to experiment with that as well. So there might be a 3.0 resonance relay in the future using some kind of Schottky. So by reducing the recovery rate of the diode, we are allowing less wasted energy to escape in the form of leakage. We're allowing more of that back EMF to bounce off of it and go back into the coil and to the battery, I guess. Now, looking back, none of these discoveries happened in isolation, right? Every experiment built upon the previous one. Every observation gradually revealed a larger pattern. So going into that, a useful scientific model, any useful scientific model, doesn't merely explain previous observations, right? When you're trying to develop a model, it should be able to make predictions about future experiments. So that's really the whole basis of building a model. The model proposes, at least the synthetic AC model that we're building here, proposes that the system is essentially geometry dependent well before it is circuit dependent. Meaning, by changing the geometry of your coil using the same circuit, you would not be seeing the same smooth sine wave on the macro scale, for example, in our lightning thief system. You know, we can clearly see this play out using the lumen lamp pancake coil as a control experiment. So this is indicative of field cavitation, right? So some final thoughts, though, is that this journey didn't begin with a theory, right? I didn't start out with a theory of how this was all working. It really started out with a passion to try to replicate these experiments and validate them, specifically Daniel Nunez's experiments, which we've confirmed nearly everything we've been able to test, and some things that we haven't been able to test, I can guarantee you that they're going to yield positive results in some manner. As long as we set up the experiments correctly. But it didn't start out with this theory or this idea of understanding. It began with these observations, these observations that refused to fit neatly into existing understanding. And as much as I tried to look up, why is this happening? This is like, why is this anomaly happening? Why is this? Nothing could really explain it. So you really have to, at that point, go back to first principle thinking and just abandon all assumptions and start from the ground up. But I never set out to create a new electrical model. I simply followed the evidence wherever it led, right? I just simply followed my observations and my evidence and my measurements. And each experiment answered one question while raising two more. It really was a take one step forward, two steps backward kind of thing for a long time until we had this cohesive understanding, at least of the basics, the fundamentals. So the synthetic AC model is my attempt to organize all of those observations into a coherent framework that can be examined, challenged, tested, and, if necessary, even revised. So whether the model ultimately proves correct or requires modifications is something only continued experimentation and independent replication can determine. This is why I highly advise anybody who's interested in this stuff to check out my do-it-yourself guide linked into the description of all my videos. Because models are not protected by belief. Okay, they survive because they continue to explain observations better than competing explanations. So the more independent verifications of these phenomena that we have, the better proof, the better body of proof we have when presenting to an authoritative figure, like, say, a science board. So my goal is not to ask anybody to accept these conclusions on faith alone. My goal is to provide enough evidence and documentation that others can be inspired to reproduce these experiments. You know, analyze the data, challenge the conclusions, and decide for yourself. If these observations truly withstand scrutiny, then we've identified something genuine worth exploring, right? And if they don't, we've still learned something valuable. Either outcome moves us one step closer to understanding how these vortex coil systems truly operate under nonlinear open systems or open system circumstances. And my chat, or my video, I have a video up on my phone for chatting in on the live chat. And it keeps on shutting down for some reason. Keeps on like going back to the beginning of the video. It's really weird. I've never seen this before. So I'm gonna read some of the comments before we end the stream. We got some comments from Mike Does and some comments from Steven. Oh. Yeah, Steven says, yeah, I was going to say it's two full bridge forward and backwards. They might be talking about something else though. Mike, in my experience, but yeah, I don't know what you guys are talking about, but it sounds like a little bit of an argument there or a disagreement. Mike's complaining about the League of Extraordinary Inventors. Phil complains about not getting hired by government companies, and I told him to seek work in the private sector. GOV is corrupt, and they only hire corrupt people. I mean, at the end of the day, when you're desperate to get your work out there and to get funding for your research, you'll go to a lot of different places. You know, the private sector and the public sector alike. It's good to get grants and stuff like that, but Mike is telling the truth when he says the private sector is going to be more lucrative. However, I think the private sector is going to be a little bit more unstable in the long run because at the end of the day, I mean, depending on the type of government you have, if it's more of authoritative government like we have now, or if it's more of like a social democracy like in Finland, that would determine the outcome of your government contract. But, you know, they tend to be more stable in socialist countries. So, you know, if you're in like Finland or Norway, yeah, a government contract would be a good deal. But in the private sector, it's unstable. You know, like they could decide, oh, they're not making enough money this quarter and you know, cut costs somewhere. And that could be you, not any fault of yours or your work or your performance or anything like that. So, you know, there's a risk, a cost, a risk-benefit analysis to each situation, right? And you have to weigh it to your own individual needs and tolerances, really. Mike says the USA is power-hungry, corrupt empire, but as long as the Second and First Amendment to the Constitution remain, I will support the freedom we have. I mean, the government is highly corrupt. Yeah, our current administration is definitely the most corrupt administration we've ever seen in the history of this country, bordering, like a full-on fascist administration. So yeah, I would have to agree with you on that. But it seems like we've exhausted all of our time here on this live stream, so I'm going to end it. I appreciate everybody for tuning in. Make sure you hit that like button and subscribe for more revolutionary content on your way out. We'll be back maybe a little later with some video games. I don't know. I might be too tired. I might be back on tomorrow. I haven't decided yet. I know Friday, Mike K likes to do League of Extraordinary Inventors. Sometimes I join the podcast, so we might do that tomorrow, or I might have something else lined up. We really don't know yet, because I don't have anything planned at the moment. The research that I'm doing is extremely slow because I'm still conditioning the battery, but I will have more updates on that in the coming weeks. So we're really close to fully conditioning this battery, and I will have updates on that for you guys very soon. So hold on to your butts. We'll be back with more revolutionary content only here on Beneficence TV.
Shattering the silence, feel the power. Revelations on the rise. From the shadows, light emerges, breaking through the veils of dark. 0 points in gravity converge, yeah, dying voices. Revelation start. Ancient whispers call. They're